teach you. So, lesson 52. Chemical mixture problems. Type A. Why do you think they say type A?
Because there's active.
There will be more than one.
Dang it.
So, we're going to start out with type A, and I drew this really cool little, what would you call these?
Chemical mixture pump.
Chemical mixture containers.
Beakers.
Beakers. Erlenmeyer flasks.
Flasks.
We're going to put this solution, we're going to make it red.
Flasks.
We're going to make this solution
Blue.
blue.
The other one has to be purple.
The problem is, when I mix them together, I should get purple, but I don't have purple, so
Oh, you do
we're
though.
just going to make them.
Just put both. Put both.
Yeah, they're not going to mix, you know.
One's going to go on
It's
top.
pretty good. It's pretty good.
You get probably
Okay.
More of a Spider-Man.
So, here I have a 50% solution.
That means the other side's good.
Here I have a 10%
What?
solution.
Oh, we put way too much.
And I have a 20% solution. So what I'm telling you is that I'm going to start I've got, let's say that the red is cherry Kool-Aid, and the blue is, what
Blue
flavor
raspberry.
is blue raspberry Kool-Aid.
Lemonade.
Okay, Riley has just got this crazy idea at home that he's going to mix these two Kool-Aids.
Except I don't like cherries.
Okay? But because he doesn't like cherry Kool-Aid, he wants to pour some of the purple in there to offset the nastiness of the cherry.
What's that
So,
percent in the
I am getting there,
we can
honey.
use
Oh, this is 20 down here.
You should make the 50.
So he's taken cherry Kool-Aid that has 50% Kool-Aid and 50% water in it. So he's got some pretty hefty tasting cherry Kool-Aid there. The blue Kool-Aid has got 90% water and only 10% of the berry stuff.
That's weak.
Okay, kind of weak stuff. So what he's doing, guys, is he's mixing the 50 and the 10 to make the concentration a little bit heavier than the 10, but not as heavy as the 50. He wants 20% Kool-Aid when he's done. Okay? In fact, he not only wants 20% Kool-Aid, but he wants a total of, let's say he wants a total of 2 quarts when he's done. So when he's done, he wants 2 quarts of a 20% solution. So that's what he's trying to come up with. So what he has to figure out is how much of the 50% and how much of the 10% does he have to pour into the one container so that he gets 2 quarts of 20% Kool-Aid. Okay?
until it tastes good.
Until it tastes good.
We don't need this math stuff.
Yeah, that's what I would do. A little more.
But there are some math problems where we're not doing taste, we're doing
Hot.
medication that's actually going to go into your body and either make you better or kill you.
Okay, you can figure out what they
So,
Just the taste. We'll eyeball it.
but I'm using Kool-Aid because that's what you're familiar with medicine. Okay. So what I normally teach is I have an amount of 50% plus an amount of 10%, and that's going to give me an amount
Of 20.
of 20%. Okay? These are little amounts. How much of 50% Kool-Aid plus how much of 10% Kool-Aid? Guys, if you're going to play Batman, go outside and play Batman.
Really?
Equals the total amount at 20%. Okay? So what we're looking for is how much in this container and how much in this container we're going to need to give us 2 quarts.
It's hard to do these notes when you don't have color.
I know. Okay,
Start
so
reading iPads.
what do you want to call that amount?
X.
Easy. I'm going to call it X. So 50% of X, what does the word of mean?
9.
Times plus
Y.
10% of, what are we going to call that?
Y.
Y equals 20% of
M.
T.
Y. Z.
T for total.
2.
Oh,
We
no.
already know how much we have.
Oh.
2 quarts. All right, so
Wait,
50% of the one solution plus 10% of the other gives me 20% of 2 quarts.
Could you just change it to like 0.5x?
Yes, we will eventually. But I want you to look at this equation that you have here and tell me what's wrong with it.
Percentage
Two
sign.
variables.
Two variables, how many equations?
One.
Can't solve it, right?
Unsolved.
Next lesson.
All right, so you can't have two variables, so what we're going to have to do is figure out what we can put in there for one of the variables so that we don't have two variables. Okay, so let's look at, let's say I've got 100 gallons of a solution, 80 gallons of it's water. How many gallons is oil? How do you know?
It's a solution. Subtracted from 100.
Okay. So if we know this amount is X, we know that this amount is going to be 2 minus X. Because we have two total. We take away this amount and we get left with that amount. So I can rewrite this equation now as 50% of X plus 10% of 2 minus X equals 20% of our 2 quarts. Now I have one variable.
Why is it 2 minus X?
Y.
You told me.
I'm asking it.
No, you did. I asked you how many were left and you said 80. Because 2 is our total amount. Okay, we know X is part of that total, right? So if we take 2 minus that, whatever's left over will have to be what we're adding. Okay, so once we have this, we can change our percents to decimals. 50% is the same as,
0.5 X.
we're going to distribute. Plus what?
1.1 times 2.
Which is?
0.2 minus 0.1.
Okay. What are we going to do with all that? Huh? 0.6x equals what?
Wait, how did you get 0.6x?
5 plus 2 is 7 minus 1.
Oh, the 2 is an Wait, the 2 is not an X. The 2 isn't an X.
Oh. See?
It should be 4X. Right?
Okay.
I knew it.
So it's 0.2 plus 4.
It should be 0.4X, right?
0.4x.
Oh, here?
Point.
Yes. All right, so 0.5x plus 0.2 minus 0.1x equals 0.4. Okay. So we combine this and get what?
0.4. X equals 0.2.
So 0.4x equals what?
0.2.
So x equals,
0.5.
what's 0.2 over 0.4?
Come on.
The answer is 2.
0.2 divided by 4?
0.5.
0.2 divided by 0.4, is that what your calculator says?
Yeah, that's what I
It's
got.
1.5.
Okay, 0.5. So,
Yeah, 50%.
how much of the 50% solution do we have to put in there?
Half of
How much?
Half.
A half of what?
Of 100.
Half of a quart. And how much of the 10%?
1.5.
Does that make reasonable sense that we're gonna have to add more to of the 10% than we are of the 50%?
Yes.
Why does it make sense, Ben?
What?
Oh, I thought you said yes, it
That was
does.
Michael. Whatever.
Anybody know why it makes sense?
Because there's
you have
more.
to water down the 50% solution.
Yeah, we've got a lot of watering down to do. So that 10% is gonna need more to, because our ending, our 20% is closer to 10%. So that means we're gonna have to add more of this so that it doesn't, you know, if it was 40% here, we'd have to add a lot of the 50% to keep it concentrated.
Let's check it.
Okay, so the way you do these,
Let's see if that.
the percent times the quantity plus the percent times the quantity equals the n percent times the n quantity.
That makes sense.
Oh.
Does it?
No.
Can you say that again?
No, I get what you're saying.
What was that again? Percent times the quantity plus percent times the quantity.
Equals the end percent times the end quantity. All right, so let's look at another example. A chemist has one solution that is 10% salt. And 90% water, and another solution that is 2% salt. So we have two solutions. So we've got this one that's 10%, and we have this one that's 2%.
Hey, I
Okay.
bet you could use this to make Kool-Aid if you wanted to make an amount on there that wasn't on there.
Yeah,
Wait, they're both salt.
go back to sleep.
Wait, they're both salt.
Yeah, they're both salt.
They're both salt. One just has higher concentration.
So crazy.
Okay? I want to end up with 1,400
Percent.
milliliters, which is 1.5 liters, which is a little bit bigger than one of your water bottles, like Tim has there on his desk. That's how much I want to end up with. And that's all I'm told. So, I'm sorry?
Is this all pouring at a certain rate?
No, we're just finding out how much salt, how much of each of these I'm going to need to get that at a 6% solution. So is my number going to be closer to 10 or
So
closer
we
to
actually do
2?
know more.
Closer
We know
to
it's 6.
Is 6 closer to 10 or 2?
No. Same.
Thank you. Halfway between there, so we can't, so it's going to be pretty close to the same amount we'd be getting done.
You don't round up.
Okay? So, we're going to take the amount. What are you going to call the amount of your 10% solution? We're going to call it X. So 0.10X plus
0.2y.
0.2Y, if you want to do it that way, equals I'm sorry, not 0.2.
0.02. Yeah.
0.02Y equals 0.06 times 1,400. Okay, so my X and Y are quantities. My 1,400, I like to put them in parentheses because it shows kind of that it's a container. It has something in it. Okay, so we're going to leave our 10% or our X, our quantity of 10%. What are we going to call our Y value?
114 minus X.
Good. 1,400 minus X. Okay, so go ahead and find X for me.